Howdy. Thank you for your kindly consideration taking this solo presentation in addition to my team poster section. My name is Yang. I'm a PhD student from Biological and Agriculture Engineering. Today, I'll be presenting the project topic, Impacts of Human Activities on Climate Change. Is it climate change or global warming has become highly political debating. Before 2006, the public tends to believe the climate change happens in the natural order, where the surface temperature bouncing up and down by nature. However, as more studies revealing evidence that our Earth is getting warmer, and one popular hypothesis is that the human activity and its byproduct are contributing to the global warming. Now the internet search appears that more and more people believe our Earth is getting warmer, and there might not be a turning back. In this study, I'll be showing some graphical evidence of the global temperature trend and within those countries of interest. I will also show the computed probability of human activity that might affect surface temperature changes using random forest regression analysis. First, the temperature change here is referred to temperature anomaly. The temperature anomaly is a calibrated term that reflects the temperature change in specific area, which is basically the difference between temperature measurement at the time of sampling and the baseline temperature in that specific region. Therefore, we can avoid comparing apple with orange. For example, comparing absolute temperature in Africa with the absolute temperature in Canada would make no sense. The baseline temperature is the average surface temperature between 1951 to 1980 per specific region or country, and the temperature anomaly is reported in Celsius. Human activity could possibly trace back to the 18th century when industrial evolution started. However, the historical data is nearly unavailable, and the modern record just came into public's eye a few decades ago. In this study, I will break down human activities into 4 categories, which are population growth, carbon dioxide emissions, primary energy demand, which sums up all the fossil fuel, natural gases, sustainable and renewable energy, etc. And the last category will be generated electricity. Note that the energy conversion always comes with some efficiency loss. And electricity is hardly being stored, so if there's any stored electricity, that will be negligible. So throughout this study, I will use electricity consumption just being straightforward. I have also selected 9 different countries, which are rated top 9 contributing countries for Bitcoin mining. They are Canada, China, Germany, Iran, Ireland, Kazakhstan, Malaysia, Russia, and USA. The study time span was limited between 1965 to 2000 due to the data availability. Let's look over the table 1 at the top right. Here are some data points I think it's interesting for different time. In 1960s, it is wonderful days where the weather is nice, only 2.3 billion world population, plenty of natural resources to be developed. In 1980s, the temperature became warmer a little bit, but it's still okay. I was born in 88, still pretty nice overall environment. In 2000, we started to have some things nicer than TV and refrigerator. It's called PC and internet. World population almost doubled, and the temperature is half degree warmer than 40 years ago. In 2010, our surface temperature has passed over 1 degree Celsius warmer, a lot of countries developing in full throttle. I was in college and I have 2 times more competitors for jobs than 50 years ago. Last year, our surface temperature has passed over 1.5 degrees Celsius and still going up. All the human activity index was double or triple. Now let's look at the figure 1. Here I'm showing a normalized global trend along years. All the variables were normalized between 0 and 1, so it shows the trend without being biased by absolute scale. The red dash is presenting the temperature anomalies where it's linearly increased along with all human activity variables. The purple line in the electricity consumption, it was first reported in 1985. That's why there's a gap. Same happens to the pink line at the bottom, the Bitcoin electricity consumption, which just started reporting in 2010. Now we have seen the global trend is indeed increasing. But is this phenomenon applying to other countries? Well, unfortunately, we are seeing this figure 2, the heat map, which blue is cooler and orange is warmer, that the selected countries are showing the same temperature increase every year, basically following the global trend. But does that mean human activity contribute to the global warming? In next figure, I will show what is the probability that human activity indeed is impacting global temperature. I used random forest regression analysis to see how closely human activity is related to global temperature changes. What random forest regression analysis does is it randomly take out 20 samples at a time within a variable and regress that variable against temperature anomaly. Then form a smaller regression tree. And this is one complete iteration. Repeat this process until all the samples in variable and all variables were exhausted. The final result gave me a forest containing 244 intermediate nodes and 247 leaf nodes, with the deepest of 8 layers intermediate events. As you can see here, the green represents the leaf nodes. This is only a small branch of the decision tree, the forest, just for demonstration purpose. And the blue and orange combined, that's the intermediate nodes. And I'm using blue to show that it's a natural climate change. And the orange is when the temperature anomaly is impacted by human activities. Overall, human activities weighs in about 48.4% of the intermediate events. That being said, there's half chance the climate temperature is regulated by its nature, and half chance that we people are causing the ascending surface temperature. In conclusion, the land surface temperature is increasing globally and per country of interest, along with the increasing trend of human activities. Random forest regression analysis shows a very good potential to be used in computing the climate event probability. The next step is to gather a comprehensive dataset contains more data points from different countries and regions in order to analyze the full dynamic worldwide. Lastly, all the source code and clean dataset is available on my personal GitHub repository. Thank you, and let me know if you have any questions.